As we are talking about the distributed system, so in distributed system, in 1 second, hundred of requests are coming, like in case of Amazon or LinkedIn or Facebook. So this huge number of events coming in a very small amount of time, the messaging system like ActiveMQ can't able to handle it. Why? Because this ActiveMQ works on messaging system. It's a messages. But here we are talking about the streams. We have a continuous streams that are coming. So when the requests are coming in the form of streams, then we need a distributed messaging system like Kafka. So Kafka is very famous nowadays among the interview room, as currently all the companies are moving towards distributed system, so they needed developers who have good understanding of the Kafka. And one of the best feature of Kafka is it is highly available and resilient in node failures, and also it supports automatic recovery. Kafka is very fast, scalable, and fault tolerant, and it works on publisher subscription messaging system like Kafka. So let's see few components of Kafka. It has Kafka broker, then Kafka topic, partitions, consumer groups, and of course the producer and consumers. So let's discuss these components in detail. Kafka is also a messaging system, so it also has a producer and consumer. Producer will send the data and consumer will receive the data. And we have the different set of machines. So this different set of machines, we call it Kafka broker, and it create one single clusters. So one cluster contains the different set of machines. Individual machine we call it broker, and completely one cluster we call it as a Kafka clusters. So producer will send the data to a Kafka clusters, and Kafka cluster will, from the Kafka cluster, consumer will receive the data. Now let's see what is the Kafka topic. So to understand the Kafka topic, let's see one example. Consider this is my Amazon inventory and these are the different vendors. So these different vendors try to communicate or send all the product details to the Amazon inventory. So what we want that all these different vendors will send the details of all the products to Amazon inventory. So what we thought, let's implement Kafka in between. So we implemented Kafka for transport the data from these vendors to this inventory system. And all these vendors works as a producers. So these are the different producers are there. And they send the grocery item details in the form of message to a Kafka topic grocery, and from this Kafka topic it is delivered to the Amazon inventory. So that's the meaning of the Kafka. All the producer will send the data or the streams of data to a particular topic, and with that topic it will be delivered to a consumer. It can be multiple producers, it can be a single producers. Similarly, let's say if these vendors wants to send the detail about the electronics items, so we create another topic, let's say electronics, and all these different vendors send the data related with the electronics. And at the Amazon inventories consumer side, we can able to get the data related with the electronics consumer, or similarly we can able to get the data with the grocery items. So that is what the topic is in case of Kafka. So basically the Kafka topic is the named streams of record. So this Kafka topic can be very huge. So this Kafka topic can be, let's say we have the distributed logs from the different machines. It can be a different huge list of database record in case of sharding. So it can be anything. And this Kafka topics is been distributed among the different brokers. So as we have already discussed, this Kafka topic can be very huge. So generally we broke up this Kafka topic into the different partitions. It's nothing but we are actually dividing the messages. So let's say in our example we consider that we are getting a logs in the form of input from the different producer. So we distribute this log in the form of different partitions P1, P2, P3 and P4, and then we put all this different partition into the different brokers. So broker 1 store the partition P1, similarly P2, P3 and P4. So that's how we able to manage the huge distributed systems. Even if we have the streams of log, we can easily able to distribute that among different brokers. So as the Kafka can handle the huge number of producer, similarly it can handle the huge number of consumer as well. So for simplicity, I assume that let's say at the receiver side we have the two consumers. So this consumer will take the data from the different partitions. So this partition P1 will deliver to a consumer 1. Similarly, P2 will deliver to the consumer 2. P3 will deliver to the consumer 2 and P4 let's say consumer deliver to a consumer 1. So one consumer can take the data from the different partitions, and we have this consumer group as well. So we can select some set of consumers and create a consumer group as well. And one consumer can take the data from different brokers, but different one broker cannot send the data to the different consumer inside a one consumer group. That is not valid, because as we have the same data which we partition into the four parts. So these are the four partition of the same data. Now let's say this is the one partition, and if the same partition we are trying to send to the consumer 1 as well as let's say consumer 2, and these two consumer are actually the part of the same consumer group, so it's actually the duplication of data. So that's why in Kafka one particular partition can only be delivered to a one specific consumer inside a consumer group. But if you have another consumer group, then you can send the data of that particular same partition to different consumer group, but not the consumer in the same consumer group. So now we understand all the terms in Kafka. What is consumer group, consumers, broker, Kafka topic, and then we have different partitions, Kafka clusters. As the Kafka is a distributed system and it works on the clusters of machines, and also the Kafka spread the data in the form of partitions over the various system in the clusters. So what if the case is one of the system in the cluster is down? So what happened to our data? Of course, we can't able to get it. So it's a fault. So let's do the fault tolerant of it. So fault tolerant is very common term in the distributed system. We saw the fault tolerant in microservices as well, where we use the circuit breaker to achieve the fault tolerance. So let's make our Kafka system also fault tolerant, so it continue operate properly in the event of failure of some of the nodes or components. So logically what we should do here, so we should create a multiple copies of these partitions and store that into the multiple machines, and we call this system, we call this concept as replication factor. So what it means, if the replication factor is 3, it means we have two more copy of this particular partition P1. Let's say these are the two copy of this particular partition and store that into the broker 3 and broker 4. So even if this broker, if this system or this broker is down, we can still able to, our Kafka system is still able to operate it properly. So here replication factor we set on the Kafka topic, not on a partition level. So what this means is, if the Kafka topic, at the Kafka topic level, if we set the replication factor as 3, it means it creates the two copies of all the partitions for all the partitions. We cannot create just the 3 copies or the 2 copies of a specific partitions, but we have to set that on a Kafka topic level, so it applies to each and every partitions. So there is one more term here and we call it leader. So basically for every partition one broker is elected as a reader. So in this case, for this partition P1, this broker works as a leader, and rest all copy of partitions are the followers. So for every partitions we have one specific broker as a leader, For P2, this broker is a leader, and similarly for P3, this broker is a leader. So what the meaning of that particular leader? So basically, this broker or this leader only communicate with the all the producers and consumers. Rest copies won't communicate with the producers and consumers. So this leader will receive the messages from the producers and correspondingly send the acknowledgement to it. And same time, it also communicates with the consumer only. And all the followers are actually just get updated with all the data that the leader have, but they don't communicate with the producer as well as the consumers. Kafka is a huge subsystem, so we need someone to manage that. So Kafka uses ZooKeeper to manage the clusters of machines. Please note that you can't run Kafka service without first installing the Apache ZooKeeper. And this ZooKeeper and of course this Apache ZooKeeper and Apache Kafka are open source. So you can easily able to download it from the internet. So this ZooKeeper actually do a lot of stuffs for Kafka. So the first thing it do is ZooKeeper maintain all the list of all the brokers that are currently working in the Kafka system. And how it do that? So this ZooKeeper actually regularly sends the heartbeat request to each and every broker. So it at any moment of time, this ZooKeeper got to know that a particular broker is dead or alive. Then let's say if a broker node by some reason is shutting down. So it's a ZooKeeper responsibility to tell all the replicas to act as a partition leaders in order to fulfill the duties of the partition leaders. Then the third responsibility of this ZooKeeper is this ZooKeeper store all the configuration of this complete Kafka systems. Like it stores the number of partitions of each Kafka topic, because in Kafka system there are multiple Kafka topics and each and every topics have a multiple partitions. So all these details are stored in Apache ZooKeeper. Then also the locations of all the replicas of a particular partitions, and also which broker node is elected as a leader and which broker nodes are followers. So all these details are stored in the form of configuration in ZooKeeper. So that's all the basic introductions of the distributed messaging system Kafka.